from the Department of Electrical Engineering will be handling electrical lab for you guys. You can hear it?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes. So since this is my first class, I would like to know what you know about this basics of electrical engineering from your side, and then I can start with it. Hello.
Mainly like circuits.
So far, what all you have learned? Can you tell me? Anyone?
We have done finding the voltage and currents. Then in the electricals class we had, ma'am has just started with the syllabus, so not much has been cleared yet.
Mm-hmm. So do you know about active elements, passive elements, all that?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. So can anyone tell me what is an active element? Yes.
Ma'am, an element capable of generating electrical energy.
Does
On its
not
own.
depend upon other circuits
So it doesn't
for
depend on
voltage or
any
current.
other sources.
It is a source of its own.
Yeah, so it doesn't depend, correct?
Ma'am.
Yes, ma'am.
Yes, ma'am.
Whereas in the passive, it depends on the voltage or
Like,
the current source, correct?
yes, ma'am.
Yes, ma'am.
Yes, all of you agree to that? Yeah.
Yes, ma'am.
Yes. Yes, ma'am.
So now in this lab, actually, we deal with uh, your Ohm's law. You have studied Ohm's law?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
What
ma'am.
is Ohm's law?
Like according to Ohm, V is directly proportional to I, and for a
I is
constant,
proportional to V or V is proportional to I?
V is directly proportional to I.
Actually, I is proportional to V. Okay.
Okay, and so
When
for
do
a
you get that? When do you have current in an electric circuit? When do you get current in an electric circuit?
When we have difference in potential at
Uh,
two end.
if it is a closed circuit or open circuit?
closed circuit.
Closed
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 circuit.
circuit.
circuit, ma'am.
Closed circuit, correct? In any closed circuit means you will have a wire which is closed, correct?
Yes,
ma'am.
Correct.
Yes,
The
ma'am.
wire is a conductor or an insulator.
Conductor, ma'am.
Conductor.
What happens if there is an insulator?
The current will not
Can
flow.
one flow.
The current will not flow, correct? Yes?
Yes, ma'am.
Yes, ma'am.
Yeah. So you have heard about Ohm's law, correct? So can anyone tell me when you cannot apply Ohm's law to a circuit?
When there are non-ohmic devices in there, or when the medium is a vacuum.
That is, it does not obey the superposition theorem or the linearity in principle, correct?
Yes, ma'am.
Yes. So that means they are not following the procedure of y is equal to mx, but it is behaving like a non-linear characteristics, isn't it?
Yes, ma'am.
An example for it, if I can say, the resistor, will it behave as a linear or non-linear?
Linear, ma'am.
Linear. Why linear? I will draw and show you. All of you can see the whiteboard, or should I use something else? Paint. I'll use paint for you guys.
Okay, ma'am.
Okay, ma'am.
Can you all see the paint?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
So
Yes,
what are
ma'am.
characteristics of V and I? It is like this, correct?
Yes, ma'am.
Yes, ma'am.
Yes. Right? So whatever you get here is the resistance, correct?
Yes, ma'am.
Yes, ma'am.
V is equal to I R, isn't it? So it is directly proportional. Now you come to the diode characteristics. Transistor, all that. Does it obey the property of ohmic like this or not?
No.
No, ma'am.
No,
No,
ma'am.
ma'am.
So it behaves like a non-linear
Non-linear.
character, correct? Sometime it behaves as linear, then it attains a saturation value. Such a behavior is called as the non-linear characteristics, okay? Right? So the devices which obey the linearity property, the superposition theorem, is always you can apply the Ohm's law. Otherwise, you cannot apply the Ohm's law. Correct? Yes or
Yes,
no?
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. So yeah, now I would like to ask you a question. Can you apply Ohm's law to any circuit? Hello? Can you apply Ohm's law to any circuit? Under what condition you cannot apply Ohm's law to a circuit?
When there's change in temperature and pressure.
No. That you that is resistor also, R is equal to R naught into 1 plus alpha T, actually speaking.
Okay.
Correct. So linearity property, it will satisfy at some stage actually, because it depends on the type of the material, and based on this your alpha will change, correct?
Yes, ma'am.
Yeah. Now okay, I'll ask you one more hint I will give you. Can you apply Ohm's law to any complex circuits? Whether it is easy enough to apply Ohm's law to a complex circuit.
No, ma'am.
It is not very easy, correct? When you have multiple circuits connected, for example, you have circuit like this. You have a meshed circuit. Can you apply voltage across each voltage and current across each element by just using voltage, the Ohm's law?
No,
No,
ma'am.
ma'am.
No, ma'am. It's quite difficult.
It is quite
Difficult to.
difficult, correct?
Yes, ma'am.
So then we cannot apply Ohm's law to a complex circuit. So in such cases, we go for
Kirchhoff current law.
KVL.
KVL.
Kirchhoff current law.
Yes, sir.
Got it?
Yes, ma'am.
Yes, ma'am.
To realize any complex circuit like this into a simpler voltage with one resistor, okay, we go for theorems like Thevenin and Norton, okay. To realize a complex circuit into a simpler network, we go for Thevenin and Norton, or even the maximum power transfer theorem. All of you understood?
Yes, ma'am.
Yes, ma'am.
Anyone has any doubts? Hello?
No, ma'am.
No, ma'am.
Anyone is having any doubts?
No, ma'am.
No,
No,
ma'am.
No,
ma'am.
ma'am.
No, ma'am.
Okay.
No, ma'am.
So now, can you see here? This is a conductor, correct? This is a conductor, correct?
Yes, ma'am.
So
Yes, ma'am.
when you see conductor, conductor is nothing but one wire, correct?
Yes, ma'am.
So this wire, is there connections at your house?
Yes, ma'am.
Yes or no? Yes. Okay. So kind of domestic wiring also you'll be discussing in your syllabus. So in this thing, in your curriculum, with having this, you know, details about whatever I said, if you see, we have verification of KVL, KCL for DC circuits. You know that we have two circuits, correct? AC circuit and DC circuit to
DC.
solve any network, right?
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So then we have superposition theorem, Thevenin theorem, this thing. This is KVL, KCL thing. And any transformer, you can see that different types of voltages you get. So how to realize in connections of star and delta connection. And if you see transformer, some kind of nonlinear characteristics also, you should understand the BH curve and all, correct? So we have introduced a single phase transformer and then wiring, domestic wiring also to switch on one lamp, and DC shunt motor also is used. So if I see you in this thing, I'll give you one example again. Why we require to understand the shunt motor or whatever, the DC motor or induction motor, why it is required for us to understand in your curriculum. Okay. Okay. Now, can anyone tell me, when you all of you have mobile phones, correct?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. So, do you charge your mobile phone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, correct. Now, what is the voltage you are getting at the terminal where you connect adapter?
220
What is the
volts.
voltage do you get? You get AC or DC and voltage.
AC voltage.
AC voltage single phase at around 230 volt.
Yes, ma'am.
Okay. So your devices is taking AC or DC. So the adapter, whatever you're using, no, it has some kind of regulator. So it has some circuits to make feasible for your mobile phone, because mobile phone directly doesn't take 230 volt, correct?
Yes, ma'am.
It takes 5 volt like that, right? So that
Yes.
conversion will happen in your adapter. So that is why circuit analysis is important in real time to understand, even though you're computer science engineers, but you should know some kind of a basics what you use at home. For example, do you use geyser at home? Heater?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes.
Yes, ma'am.
Yes. Do you know there is a coil there?
Yes, ma'am.
Do you know how that water gets heated? Have you observed anything or have you thought about it? Yes, have you thought about it?
No, ma'am.
So next class will
There are
think,
some
tell me
there are some
why
coils in it.
how heater will operate. Yes. Hello.
Yes, ma'am.
Hello.
Yes, ma'am.
Yeah. Next class, will you tell me how heater, why power is required for the heater to switch on?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes. Yes, ma'am.
Yes.
Yes,
So
ma'am.
do you use refrigerators?
Yes.
Yes,
Yes,
And
ma'am.
ma'am.
Yes,
why
ma'am.
power is required there? Can you tell me?
Ma'am, to compress the air that is circulated in the refrigerator.
There you have a gas, correct? So compression will
Yes.
have with the naphthalene gas or some gas is there, correct?
Yes, ma'am.
So why? So you should answer me all these questions in my next class, right?
Yes,
So
Yes, ma'am.
Okay, ma'am.
elementary electrical engineering is required to understand some of our basic things which is required. Okay. So
Okay,
yes,
ma'am.
ma'am.
yeah. So you can see in your syllabus we have listed all that which is required for you to understand. I'll give you another example of a car. How many like Pyrus car or Honda City electric hybrid electric cars? How many of you like? Or have you heard about it? These
I've heard
electric
about that.
cars also
Yes,
Heard
run
about it.
yes, ma'am.
using electricity. So if you see most of the automobile, they are trying to convert the IC engine from the petrol conventional to a no
Electric
to
battery
renewable
system.
electric thing, correct? So if you see now, paint is 1 second. The meeting is there, no? I don't know. What has been shown to you now?
Ma'am, the syllabus.
Uh-huh.
Like now it's
Right now in Teams, ma'am.
Okay. Now, consider a car, okay? Yes. So when you apply a force through your IC engine, through the gearbox, what will happen to your car? Will it move? Will your car move to front?
Ma'am, could you repeat?
You have an IC engine, okay? Petrol is there, and your gearbox is there, and will your car move?
If ma'am
Is
it is
that possible?
Yes, ma'am.
power on.
Yes?
If we move, it will move. Matlab.
Yeah. So it will move, correct?
Yes, ma'am.
Another option is you have an IC engine, gearbox, or you have, say, DC motor. Okay. You have a gearbox. Will your car move? You have ICE induction motor connected to gearbox to the wheels. Will your car move? If you consider one automobile only, various options are available for an automobile to travel, correct? So hence, if you
Yes, ma'am.
see all the electric uh, uh, parts in terms of a circuit, in terms of a machine, it is important for every engineer to understand, at least to know the basics of the electric aspects. Okay. So with this, I can come to a conclusion that it is required each one of us to know some of the basic elementary things in the electrical engineering. Okay. So I will give you an example so that you just have to work out for a few minutes, and then we will see how to carry out in our next further labs so that at least you get interest to work on. Okay. I'll give you one circuit. Can anyone tell me what is the current flowing here in this circuit?
0.25.
0.25.
0.25 ampere.
So how do you calculate? I is equal to V by R, correct?
Yes, ma'am.
5 by
Yes, ma'am.
20 is 1 by 4th, which is nothing but point
25.
5.
25 amperes. So you should remember that always you should associate unit in whatever you tell. Okay, without unit, it is not good practice. Got it? Yes?
Yes,
Yes,
ma'am.
ma'am.
Yeah. Same thing. I will ask you to open. If you have a computer with you,
Yes,
you
ma'am.
can open this. NI. Can you open this in Google? And can you log in through your Gmail account? And this is available even in your Android devices. Can you open this, all of you? NI simulator, online simulator, NI multisim. Hello.
Yes, ma'am, it's running.
Ma'am.
Yes, ma'am.
All of you open. Can I tell
Ma'am,
you
it's
now?
running.
All of you can see my multisim window.
No, ma'am.
No,
No,
ma'am.
ma'am.
No, is it?
No, ma'am.
Yeah. Now you can see.
Yes, ma'am.
Yes,
All
ma'am.
of you have opened this window. Yes. Now, can you see here the passive devices in your left side? Hello.
Yes, ma'am.
All of you can see here resistor. Yes.
Yes, ma'am.
Just click on this. Place it on the window. Can you see here the label R1 and 1 kilo ohm? Yes. All of you can see this?
Ma'am.
Huh?
Yes, ma'am.
Yes. Now you double click on this and can you see a pop-up window has you have got it?
Yes, ma'am.
Yes, ma'am.
So can you see here I can change the value here to 20 ohms. Can I change here? Can you see here I have changed it to 20 ohms? Yes?
Yes, ma'am.
Huh? Yes, all of you have got
Yes,
this?
ma'am.
Yes, ma'am.
Yes. So what do I need next? I need a voltage here, 5 volt, correct? So can you see here the sources? Can you all see here sources?
Yes, ma'am.
Yes, ma'am.
Can you see here DC voltage?
Yes, ma'am.
So just get that, place it here. So I need not change because this is already 5 volt, correct? Right?
Yes, ma'am.
Yes. So now can you see here if I go to the node, can you see one wire indication has come here like this?
Yes, ma'am.
Just connect it to the node.
Nice.
Okay. Okay, all of you got it?
Yes, ma'am.
So I need one ground to connect the source to the. So again, connect it to the point. back to this. All of you did this? Yes? All of you did this?
Yes, ma'am.
Yes,
Anyone
ma'am.
is having any doubts?
No, ma'am.
Yeah. Now, can you see here this current like this? Voltage analysis and annotations. All of you can see this?
Yes, ma'am.
Just go here, current. Place it. Okay. Now go here, run the simulation. Can you see here 250 milliampere is coming, correct?
Yes,
that is
ma'am.
but 0.25 amps. So did you verify the answer now in theoretical and practical?
Yes, ma'am.
So is it simple for you to understand?
Yes, ma'am.
Yes. Anyone is having doubts here?
No, ma'am.
Okay. So I will give you the now. Okay. Now, what you have to do is for today, all of you should have a separate observation book in whatever we teach on the daily basis. Okay, on every class you should have a noted down because that carries marks. Okay, right?
Okay, ma'am.
Ma'am.
You should have separate observation book, and the way you have to write your electrical laboratory. Second, I don't know where the file goes. Can anyone see? Only PPT is available. Yeah. So what you have to do is we should write the experiment like this. Experiment 1, verification of Ohm's law here. Okay. You have to write introduction and purpose of experiment, what is Ohm's law and things like that. Okay. What is the aim and objective you have to write. What is the component you have used you have to write. And the circuit diagram, whatever we have written on the software, you have to write that. Okay. What is the experimental procedure, you have to write it. Okay. And here what is the current in theoretical, in simulation. Once you come to our laboratory here to attend an offline class, then you keep one table for experimental values. Okay. Some observation you have to give after evaluation in the analysis and discussion. Finally, you give a conclusion. So the same thing you have to follow for the experiment 1, which is not here. Verification of Ohm's law is not here, but you have to write it. Well, if you got it?
So we need to write this in a separate book, all of this.
Yes, yes. Okay. I will be sharing you this document, and if any changes further, we will update you.
Ma'am, should we write this by the next class?
Next laboratory.
Okay.
Okay. Anyone is having any doubts in the session what we conducted today?
No, ma'am.
So anything you want to ask, you can you are free to ask. So
Ma'am,
Ma'am, could
every
you-
week today we have your class.
Mhm.
Every week today we have
Yes,
every week
yes.
on Wednesdays.
Yes, yes. Now newly they have changed a few timings. According to that, today is the timings.
Okay, ma'am.
Ma'am, could you once again can you explain it again, the writing thing,
Okay.
the separate observation table?
Section B, people have done it. I'll send you whatever they have written to your WhatsApp group. You can share
Okay,
that.
ma'am.
Yeah.
Okay, ma'am.
Okay. So we'll end up for today's class. Okay. Further, we can show you some of the video sessions of the conduction of experiment for the offline, and then you can try to relate with whatever way you which is convenient to you. Is it fine? Yes.
Yes, ma'am.
Yes, ma'am.
Ma'am.
Yes, ma'am.
Okay. So we'll end session for today, right? Yeah. Thank you.
Thank you, ma'am.
Okay, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.